Hello AP Statistics students. In this video, we're going to take a look at one thing on the calculator that you might have to do for these inference problems when you've got the four-step procedure. Sometimes you might actually need to input some of the data into the calculator. They won't give you the summary statistics, they'll actually give you the data. So I want to take a look at how you do that with a couple of different calculators. So you won't have to watch the whole video here. You'll just skip to the part that has your calculator once we get through the beginning of this problem here. Okay, so here is our scenario for this. A manufacturer of high-resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. I did a quick Google search and I found here's all the cross sections in a monitor. Isn't that crazy how many pieces, how many layers there are to a monitor? I think it's an LED monitor. Isn't that insane? How many pieces they fit into that tiny, tiny thin screen. Pretty awesome. But this is just one part of it, right? Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process. Here are the tension readings for a random sample of 20 screens from a single day's production. I think the rest is a typo right there. So here is our data set from the 20 screens. They just give us the raw data. And from that, we need to construct a 90% confidence interval for the mean tension mu of all the screens produced on this day. So, to start this out, it starts out like any other problem. We start by stating what we're going to do. We will create a 90% confidence interval for mu, which is equal to the true average voltage reading in millivolts of the device that measures the mesh tension. All right. Next is our plan stage, right? We're going to do a one sample t interval for mu, the population average. Are we allowed to do that? So we check our three conditions. The random condition, that one's met. We have a random sample of 20. The 10% condition, do we have that one? Well, yeah, that one's just fine because we can safely assume that our SRS of 20 is less than 10%. All right, remember, we're still kind of having trouble on identifying the population. Our population here is all screens from that day's production. All right, again, I took that straight from the problem right there. We are looking at a single day's production only. That's where our sample was taken from. That's our population. Now, here's the one that we need our calculator for. The large counts normal condition. So in this case, our sample size is less than 30. So we need to graph our sample data and take a look at it. If the sample data has no skew or has very little skew and it doesn't have any major outliers, then we're allowed to proceed. This condition, the large count, sometimes referred to as the normal condition, has been met. So for that, we need our calculators. Now you could graph this by hand. That's true. Okay, you could just do this by hand, make a dot plot, make a histogram by hand. That is fine. The data is sadly out of order, which is obnoxious to do any of those by hand. Maybe less so for a dot plot, but I want to show you how to do this on the calculator. So let's start with the 84, shall we? So you go turn it on, and then what you're going to do is you're going to go to Stat, and then Edit. The very first one, we want to edit a list here. So we got L1. So the first thing to do is to type in the data. All right, so I'm going to do that here. I'm going to fast forward. Maybe you can pause the video and type in that data. All right, now you've got the data typed into list 1. So 2 things we want to be able to do with this data. We need the mean and the standard deviation. That's going to be the basis for all of our calculations. But we also need to graph it to make sure that there's not too much skew and no major outliers. So to graph this, we want to go to stat plot up in the top left. So second stat plot. We want to do plot 1 here, might as well. So we have for one variable data, we don't want a scatter plot. So first I'm going to turn this on, aren't I? Turn it on. Type, not a scatter plot. We want either a histogram here or a box plot. Either of those two would also be fine, I think. Let's go a histogram. Easiest to see shape from histogram. All right, that changes some of my options. X list, where's this list? It's in list 1, so I don't have to change that. If you need to, the list keys are on the 1, 2, and 3 buttons. You can see the second L1, L2, L3 down here if you do need to change that. Frequency, you want to keep it at 1. We don't have a frequency list, so every number happens once. So now you could hit graph right now, and you might get lucky and see it, but you probably won't. So we have to change the window so we can actually see our graph. So go to window. So our X minimum value, what's our minimum value? So you take a look at the numbers and I don't know, nothing really goes below 250, I don't think. So I'm gonna go 250 as the lower. The maximum is probably like 300 something. So let's go 350 maybe. And then what do we want to count by? The X scale is what we count by. Let's go by 20s maybe. The Y values is just how high are things going to have to go. I probably don't need to go all the way down to -10. We're not going to have any negative values in a box plot for the vertical. 10 is probably just fine for the Y value. All right, everything else I'm going to leave as is. Let's hit graph, and hopefully there we have it. We see our box plot. Am I missing a data value there? Maybe not. I thought there was one more. Oh, I went 350. Let's go up to 400. I think I was missing a value. Yeah, there I was missing a value. So now that we have a picture, we can comment on the shape of it. So when I look at this, I see that, there's no heavy skew, there's no heavy outliers. This condition is met. All right, our sample does not have heavy skew, and our sample does not have any outliers. This condition is met. We are allowed to proceed. Now, if you're on a test, on a free response section, you do need to draw the graph. All right, you can't just say that. You need to show evidence. So you would just copy this graph down. You would want to put some numbers. And so if you hit trace, it will then give you the numbers. The first bin is from 250 to 270, and the height is 4. The next bin is from 270 to 290, and that bin is only 2. And it tells you then how big each bar is quite nicely after you hit trace. But on a test, on a free response, you do need to include the picture. So yes, you still have to draw this by hand. All right, from then everything, oh wait, no, there's one more thing, right? We need the summary statistics, because if I'm gonna now do the do, right, I need to know what the average and standard deviation are of my sample data. They didn't give it to us, they just gave us the raw numbers. So we got our graph, now we need the sample statistics. So to do that, you go to stat again. Calculate is the next one you want. And we want the one variable statistics. That will give us the mean. That will give us the standard deviation. All right, now where is it looking? We want list 1. We do not have a frequency list, so leave that one blank. And then calculate. Again, if you need to change the list, L1, it's on the number keys 1, 2, and 3. So hit calculate. Then it gives you the average, so you don't have to find the average yourself. And then the standard deviation we want is S sub x, okay? We want S sub, that is the standard deviation of a sample. So 36.209 is the number we would use in all of our calculations. Be careful, you don't want sigma of x. That would be if this was a population. That would be the standard deviation. There's a slight difference in calculation, and so you don't want the Greek. All right, you want S sub x, the standard deviation of the sample. All right, with all that, you should be able to do the rest of the problem, I would think. You don't need to see me do the rest. We've done that enough, hopefully. But those are two things you might need to do on your calculator. Graph a data set and find the mean and standard deviation. Again, you go to Stat. To type things in, you go to Edit. If you want to find the mean and standard deviation, it's underneath Calc. And then to graph things, you want to go to Stat Plot, second stat plot. Now, I might recommend, now that we've graphed it and you see it, you might want to turn it off. Because sometimes when you do other graphing, having a plot, having a graph can mess things up. So you might now want to go and turn it off. All right, that's it for the 84. All right, everybody, time for the Casio. Time for the Casio. So let's see how to do this on the Casio. How do we graph our data, and how do we find the mean and standard deviation from our data? Well, the first thing is to type in the data into stat. So you go menu, of course, statistics. You have the data sets right there already. Now, if there's numbers here you don't want, like I don't want list 2 here, so I'm going to go over to list 2. I want to delete that. So I need to find the right option. So I go F6, delete all. Delete the list, F1 is yes. All right, that clears it out. Now, first thing though then is now we have to type in all of our data into list 1. So go ahead, pause the video, type all the data into list 1. Let me move my calculator over. There you go. Now you can see them all. Type all that data into list 1. All right, hopefully you've done that so you can now follow along. So first things that we got to do to check our large counts condition, we need to make a picture of this data. So to make a picture, let's see, I'm going to click F6, F6. So we cycle through the menu until you have graph up. Hopefully it's obvious that you want to click the graph setting. Now you can't just hit graph 1. We have to set up graph 1. So we go to set over here on the right. Then we tell it what kind of graph in graph 1. So right now I'm on the stat graph 1 setting. If you want to do graph 2, graph 3, there are 3 presets in the calculator. I'm going to stay on graph 1. Next, what type of graph do you want this to be? I'd recommend a histogram. So you might have to go through the menu system here until you find histogram. All right, there's histogram. Oops. Then where do you want it to be taking the histogram data from? I would recommend list 1. If it doesn't say list 1, you click F1 for list, and then 1 through 26 are your options. List 1. Frequency is 1. We aren't really using a frequency list here. The rest are just color options. All right, there we go. Now when I hit graph 1, it'll ask me, all right, where do you want this histogram to start? So you have to look at your data. What's the smallest number here? I'm starting with 250. I see a 257 here. Oh, there's a 233. So maybe I should go lower than 250 a little bit. Let's go 220. And then what do we want to count by? How wide do you want your bars? I'm going to go with 20. I think that'll be fine. So there we have our histogram. Now, what do we see here? Yeah, it might be a little skewed to the left, a little, but not much. Not enough to be worried about. I think we could still say, hey, look, there's no heavy skew and there are no outliers, so the condition is met. I think that is perfectly fine on this one. Now, on a test, if you were actually doing this, you would need a picture. You need to draw the picture on your exam to show how you are coming to the conclusion that there is no heavy skew and no outliers in this data. So again, you could do that by hand. And leave the calculator out of it altogether, but you've got the picture here. You might as well just copy it down. You will need the numbers. So if you hit Shift now, you can then do trace. Shift, and then it looks like F1. It's even on the calculator there in yellow, trace. Shift F1. It will now tell you how tall each bar is. So the first bar goes from 220 up to 240, right? And it is only 1 tall. The next one goes from 240 then to 260. It's 1 tall. The next bar is 3 tall. So it only gives you the lower value here of the bar, of the histogram bin. But you can then find the next one by going to the next. So we're counting by 20s, right? So that would help you graph this on your paper. So that takes care of the large counts normal condition. We can say the sample data does not have any heavy skew. It doesn't have any major outliers. So this condition is met. Draw a picture and it's done. Well, but now we actually want to do the interval. We need the sample statistics. What is the average and what is the standard deviation of this data? Well, we need the calculator for that too. I don't want to do that by hand. So hit escape. We're going to escape out of that as well. Now I'm back to my regular options here, right? I don't want to graph anymore. I want to calculate. I'm going to check something. I thought if you were in here, yeah, if you're in the graph, you can just hit one variable statistics. Right there is what you want. F1, that'll do it for you. That's probably the easiest, isn't it? That gives you the average right there, 306. And the standard deviation you want is S of X. That one right there is 36.209. Yes, above it is sigma, which also stands for standard deviation, but that would be if this was a population. It's not a population, it's a sample. So we want S of X, 36.2. And then you can do your calculations as always using those two numbers. You have the sample size, the standard deviation, the average, all the things you need for a confidence interval calculation, right? But let's say you don't want the picture. I will show you the regular way of doing it. You go to calculate, and there you have one variable statistics again. Now you might need to set it up. So set, make sure you're looking at list 1. Make sure you're looking at a frequency of 1. If you're doing 2 variable statistics, there's X and Y, but we are doing 1 variable. Then if you hit 1 variable statistics, it will show you the exact same information, but it is kind of nice that you can get that right after the histogram on the graphing screen. So that is how you would do all that on the calculator if it wasn't given to you. So remember, you can graph it, and then calculate here will give you the summary statistics you need. All right, that's basically it for the Casio. Hopefully that makes sense. Alrighty, last but not least, I know there's a few of you with the HP Prime. Let's take a look at the HP Prime. So if I were to do this problem on this calculator, I would need to first graph this, right? The large counts normal condition says we have to look at the sample data to make sure it doesn't have any skew, doesn't have any outliers. So to do that, you go to apps. Oops. I have to exit out of the, where is exit? There we go, apps. We want statistics 1 variable, okay? Statistics 1 variable. First thing you have to do is type in all the numbers. Type in all the numbers. So pause the video maybe, do that, type in all the numbers. All right, first things first, one real nice thing about the Prime is it's really easy to find the summary statistics. You just type right here, stats. That will then tell you a lot of things that you need. Big one here, X bar. The mean is 306. We're going to need that when we actually do our confidence interval. And then right below it is the standard deviation, the sample standard deviation of X, which is 36.209. We will also need that when we do our confidence interval. Okay? So those are 2 important things that we need. But before we can even do the confidence interval, we have to make sure that we are allowed to do our confidence interval, right? So we have to graph this and make sure that there are no outliers, no big outliers, and there isn't any heavy skew. So to graph it, we want to essentially go over here to plot. Oops, I have to escape, don't I? All right, back here, we have to go to plot. We want to draw this graph. Now, if you hit plot, that won't be there yet, okay? So how do we make this picture appear? Well, you go to symbolic view. All right, this is where your equations are essentially usually, right? You go to symbolic view. You tell it you want to look at D1, because that's where we typed in all of our statistics. You tell it you want a histogram. Now, there's many other to choose from. Kind of cool. But in this case, we do want the histogram. All right, that's basically it from this screen. Now, I'm guessing, though, if you hit plot, you still won't see the graph because the window, you're not looking in the right place. You just have to tell it where to look. The graph is just way off. If this is blank, the graph is just way off to the side. So you have to go to plot setup. Okay, so shift plot setup. Now, first, what do you want the width of your histogram to be? So if I go back to my numbers, there we go. What do we want the width of each bar to be? In this case, I picked 20, but that is different for every data set, right? All right, what is the range of our data? So how low does this data go? Now I put 250, but I see a 230 here. So I need to change that to 220. And how high does it need to go? I think 400 is plenty. I don't think anything goes past 400. So 400 is fine. All right. Now, what do we actually want the window to be to show us this histogram? So what's the smallest X value? Well, I should at least go down to 220, right? Because that's where my histogram is going down to. And the highest, I might go 400 because that's the highest my histogram goes up to. Those are the same. All right, so how tall do we want this graph to be? I think whatever's there is probably fine. So let's take a look and see. If you get it close, you can always pinch and zoom, right? It's one of the beautiful things about this calculator. So now I'm going to hit plot. And there we have it. If you don't like it, you can move it around with your finger. It's one of the nice things about this calculator. Now when we look at this, yes, it's a little skewed to the left, but not enough to be afraid of it, okay? Just a little bit askew, not that big a deal. So we can then say that this condition is met because the sample doesn't have a heavy skew and it doesn't have major outliers. That was the main thing we needed to do to graph our sample data. Now, if this were a test and you were actually doing this, you would have to draw a graph of this picture. Okay, you would actually have to put this on there. So, thankfully though, it tells you how large each graph is, right? So from 220 to 240, the bar is 1 tall. Next one is 1 tall. Next one is 3 tall. So it gives you the numbers to put down on your paper, but you do need to sketch the graph. Okay? You do need to sketch the graph. That's how you came to the conclusion that the sample didn't have any heavy skew and didn't have any heavy outliers. You have to draw the picture. All right, I hope that makes sense on how to do that all with the HP Prime. Good luck.